Let us start the topic vapor pressure of unit solution, physical chemistry, class 12, CBSC, Bihar board, Jharkhand board, etc. So vapor pressure, I was explaining the molecules present in liquid state are associated with each other by very strong intermolecular force of attraction. As a result, molecules remain in liquid state. But even in liquid state, molecules are mobile. They collide with one another, and due to collision, some of the molecule present in liquid gain such amount of kinetic energy so as they overcome the force of attraction, and in such case molecule escape from the surface of liquid. This is called evaporation. This is evaporation. Now, if the vessel is covered, the volume empty over the surface of liquid is now fixed. As a result of evaporation, the space over the surface of liquid gradually get saturated by vapor molecules, and as soon as some of the molecule come closer to the surface of liquid, it get condensed. So the opposite process started taking place. At one place, liquid water getting converted into vapor, and at the same time vapor molecule converted into liquid. Rate of evaporation after some time becomes equal to rate of condensation. That means rate of evaporation is equal to rate of condensation. That is called equilibrium. Equilibrium. Okay? And all such state comes at a constant temperature. Suppose T degree C is constant temperature. What it may be? It may be any temperature, 25 degrees Celsius, 10 degrees Celsius. So at a constant temperature in equilibrium state, the pressure exerted over the surface of liquid by vapor is called vapor pressure. Once again, the pressure exerted by the vapor molecules over the surface of liquid in equilibrium state at constant temperature is called vapor pressure of liquid. So here we could understand definition of vapor pressure, and we could also understand why evaporation takes place and how, under what condition, the evaporation and condensation rate become equal. All three things we could understand in this state. Now, factors affecting vapor pressure of a liquid. There are three factors. Factor 1, nature of liquid, or better to say intermolecular force of attraction. Intermolecular force of attraction among the molecules of liquid. Point number 2, temperature. Point number 3, presence of a non-volatile solute. So let us start nature of liquid. Point number 1, nature of liquid. That means intermolecular force of attraction. Take some example. If we are going to consider the vapor pressure of water with vapor pressure of ethanol or alcohol, and also with vapor pressure of ether, diethyl ether, we will find at same temperature, suppose at 25 degrees Celsius, vapor pressure over the surface of water will be much less. If it is P1, vapor pressure over the surface of ethanol is P2, and vapor pressure over the surface of ether liquid is P3. Suppose these are the vapor pressure value at 25 degrees Celsius in 3 different samples. Then we must observe that P3 is much higher than P2, which is higher than P1, because intermolecular force of attraction among the molecule of water is much stronger than that among the molecules of ethanol, and which is much smaller, weaker in case of ether. In case of ether, the molecules are associated with weak force of attraction. Therefore, vapor pressure of ether is much higher. In comparison to ether, the molecules in ethanol liquid associated with each other by some stronger force of attraction than ether, and in case of water, the intermolecular force of attraction is strongest. Therefore, stronger the force of attraction among the molecules of liquid, vapor pressure will be much less. Weaker the intermolecular force of attraction among molecule, higher will be vapor pressure. Now, second point, temperature. Let us discuss temperature. Take same liquid in 2 different samples. Suppose you have taken water at 25 degrees Celsius and water at 50 degrees Celsius. Suppose we have taken 2 samples, water at 25 degrees Celsius and water at 50 degrees Celsius. If the vapor pressure over the surface of water sample at 25 degrees Celsius is P1 and vapor pressure over the surface of water sample at 50 degrees Celsius is P2, then we must know observation is P2 must be much higher than P1. Why? Because as temperature increases, the more and more number of molecule in the liquid gain higher kinetic energy, and larger number of molecules can overcome the force or intermolecular force of attraction and can escape from the surface of liquid. So as temperature increases, rate of evaporation increases. This causes the vapor pressure at higher temperature higher. So in temperature section, we could understand that with increase in temperature, vapor pressure of a liquid increases. Let us take third example. Non-volatile solute. Presence of a non-volatile solute in solution. Let us take two examples of a pure liquid and liquid with a non-volatile solute. Consider case it is water, and here water plus sugar solution. Sugar is non-volatile solute because sugar's boiling point is almost far more higher than water, that is 182 degrees Celsius almost, and water has boiling point 100 degrees Celsius. So much higher than water. As a result, in case of solution containing non-volatile sugar, some of the surface area of the water sample must be covered by sugar molecules, sugar particles. As a result, less area are available, less area of the liquid is available for escaping of H2O molecule, escaping of water, escaping of such molecule which are volatile, because non-volatile solute occupy a space, non-volatile solute molecules occupy a space at the surface of liquid and resist the evaporation. As a result, vapor pressure decreased in case non-volatile solute is present. However, if pure liquid is taken, in that case the whole area is available for the molecules to escape. I'm telling it at the same temperature. So at same temperature, vapor pressure of pure liquid will be much higher. Suppose it is P1, it is P2, then vapor pressure P1 must be greater than P2. So due to presence of a non-volatile solute in the liquid, the vapor pressure lowers, vapor pressure decreased due to presence of non-volatile solute over the surface of liquid, which decreases the rate of evaporation. Thank you. This is the vapor pressure.